Hey, what is good, everybody? Welcome back to the channel. It's been a while since I made a video. It's just that I've been really busy for the past 2 weeks. I guess it's been 2 weeks. But anyway, in today's video, we are going to pick up where we left off in the last video, which was we basically implemented a debugger, I believe, and set up our validation layers and the logic behind that, right? So in today's video, we're going to set up our logical devices, and I do believe we haven't really fixed or finished handling the debugger, which I guess we only need to destroy it, which is something that we're not handling yet, but we will handle that as well. So in our devices, we have two types of devices when it comes to Vulkan. So we have what is called a, well, let me start with the physical device. Physical device, you can think of this as your GPU. And then you have like your logical device. Now, I'm not going to pretend like I know much about the logical device, but those are the two different devices that we need to set up, right? And then we're going to set up these two different devices in this video, hopefully, unless I have to split the two. So we'll see how long the video takes. Okay, so we're going to start off with the GPU selection. So let's go ahead and do that. So back in our engine source code, I need to make one slight change, right? Because we have a problem, and that problem is when we create the window, notice how we're creating the window, but we don't have access to the window. It just gets created and it's shown, right? But we don't have access to the window, and we cannot pass it to anything that might need access to the window, such as the renderer. And I also made a mistake by putting the renderer at the top there. The renderer should be initialized right after the window has been initialized, because it relies on the window, but the renderer needs the window, so we need to pass in the window to the renderer when we initialize it. So a way to do that essentially is to basically store the window somewhere. So what I can do is I can just create a variable here, and then we can call this window, right? And then I need essentially this function to populate this window, okay, this window struct. So the way I'm going to do that is I'm just going to jump into the platform.h, and then right here I'm just going to add gwindow.window. I'm actually going to call it out window just to show that it's the output window that we're basically going to store out. I could have just made this return the window itself, but I'm going to choose to do it this way. You guys can just do it the other way. Instead of returning a boolean, you guys can just return the window itself, and you don't have to pass this in here as a parameter, I guess. But yeah, it's up to you, right? So I'm going to do it like this for now, because I do know in the future I'm going to change the API anyway. So this is just for us to get things rolling, right? So inside here, we want to go to where we're basically defining the window, where we're creating the window. So, and then we're just going to, and then we're just going to paste this in here. So just add a comma and then paste gwindow out window in that signature there, and then scroll all the way down, and then all you want to do here is just say out window equals to window, right? Because what are we doing in this function? We are essentially just creating the window, right? So we take this window that we're creating, because we're populating it, and then in the end we're storing it in our list of windows, but we actually want to also have access to it outside of this function. So this is what I'm doing here, and actually I'm going to need to dereference this because it's a pointer, and then I'm also going to need to dereference this one as well because it's also a pointer over here. So that's that, and that's actually the only change I needed to do. And also I noticed these two functions here. I'm just going to put a to do here because they don't really need to be here. I'm just going to remove these later on or something, right? Because they're just there for testing purposes, really, but I haven't really decided, right? So yeah, I'm still undecisive. Yeah, so I'm going to save this file here, then I'm going to come back in my main because now we have an error here. I just need to pass in the address of the window that we want to populate, in this case this window here. So now that we have this, this will now have access to the window that we're creating, and then we can pass it to any other function that might need it. In this case it will be our renderer. So let's go down to our renderer.c, Actually, let's go to the header file first, and I'm gonna forward declare struct here called G window. Make sure that it matches with the one defined in your platform.h, this guy here. So in fact, I'm just gonna copy this name, and then go back to the render.c, render.h, and then just paste it like so. Okay, and then we're gonna close that off, and then in here we're just gonna do struct G window, and then make sure it's a pointer. So I'm going to call that window. Okay, then I'm going to copy this, and then I'm going to go back into the render.c. I'm going to paste this in here, then go back into our main.c, and then in here we just simply pass in that window. So now so now the renderer has access to our window, and that's it, right? And that is simply it. Okay, so next, the other thing that we want to do is we want to add some new functions, right? So those functions essentially will fall under a new file, I guess, because since this is a tutorial, I think I'm just gonna separate things into their own files. So because we're gonna do device creation and stuff, I'm gonna define those in their own file. So let's see, Vulkan, I kind of forgot the project structure here. So in Vulkan, what you want to do is just say Vulkan, you're going to add a new file called Vulkan device.h, and then we're going to create another one called Vulkan device.c, something like that, right? And then in the C one, we're just going to include hashtag include, let's do Vulkan device.h, and then in device.h we want to do a pragma once, oopsie, like so. And then once we have the pragma once, I believe that's it, right? So I'm going to close these two files, and I'm going to come down to the renderer.c because we're going to make use of it in here, in the Vulkan renderer. Do I want to do this in here? Let's see, create instance. Wait, hold on. Render initialize. Here we're calling Vulkan create instance. In fact, I might need to refactor this. yeah, because I don't want to call this inside the renderer.c file. This should be called inside the Vulkan render.c file, and what we should be exposing instead is the Vulkan render initialize function, which should take care of calling the create instance. Okay, so that in future, if I was to basically create like a Metal API, then in here I could just, instead of calling Vulkan initialize, I can just call Metal initialize, right? And therefore I don't have to change too many things and be like Vulkan create instance, and then for Metal case I can be like Metal create device or Metal device system default device, whatever, so I don't want to have to do too many things in this API, in this interface. So what I'm going to do is so what I'm going to do is I'm going to come in here, and then instead of making this public, I'm going to remove that function. Okay, then I'm going to create another function called Vulkan initialize. Okay, so that's going to be a boolean, and then that's just going to be Vulkan initialize, like so, and then it's going to take in a window. So how do I want to do this? It's, I guess, since it's the H, I don't know if it'll cry if I redefine this again here. So let's just do struct G window up here, and then I'm gonna leave it like this, okay, like so. Then in here we're just gonna do struct G window, G window, like so, and then that will be the window, like that. Okay, and then I think that's fine, right? So this function will then be defined within the Vulkan render.c file. So right below the instance creation, I'll just put this right here, okay? And then within this, right? This is what we will then call this function. So I'm going to remove this from the render.c and put that in the Vulkan initialize function right here, because this is where we actually should be calling this anyway. So we're going to initialize the instance in this function, and then this function is going to get called when we initialize the renderer. So we're just going to do if not Vulkan initialize, then we're just going to pass in the window. Then we can do like an error, so I might need to include my logger. So let's do core/logger, and then I guess that can be like a fatal type of message and be like failed to initialize the Vulkan renderer, like so. Okay, and then we can return false here, and that's it, right? And then later on, if you add metal support, we can replace this with metal initialize or something, right? Simple. So yeah, what do I want to do? So now that we have that and we're calling that in here, let's see if we broke anything, because we made quite a few changes. So yeah, so what is this current about? We need to return something, so we're gonna return true here if everything worked. Let's try and bold. Okay, sweet. Let's try and run and see if everything still works, and indeed it does, right? So we still have everything initialized. Wait, Vulkan debugger initializing Vulkan debugger. All required validation layers are present. Event system initialized. That's interesting. Let me see something. Okay, yeah, so it seems everything is still fine. All right. Vulkan debugger initialized. Sweet. All right, fine. So if I close this, I should get a message saying that we haven't destroyed validation layers. Oh, that's because we did add this and then I removed it for testing purposes. So I guess now if I rerun this, we can just close this and we shouldn't have any issues, and it will say Vulkan debugger shut down successfully, and that's fine. Oh, so we did actually handle this in the previous video, which is sweet. The other thing now is that we need to essentially select our device. So to do that, let's go down to Vulkan device.h. Okay, and in here what I want to do is I want to define two functions, right? And those two functions will be let's do boolean, and that will be select physical device. Okay, and then this should take in a VK instance, and I don't have access to my Vulkan, so let's do include Vulkan defines.h. So that should give us access to the Vulkan instance, and what we want is the instance. Okay, and then I should have my Vulkan, let's do Vulkan. Oh, actually the way I want to do this is let's go to defines, because we have context and I don't want to pass in that context. So let's create another struct here. Let's do type struct. Okay, and this struct will be our struct that will hold our device data. Okay, so what I'm going to do is, let me think about what I want to call it first. So let's just call it Vulkan physical device, like so. Then just copy this, paste it in here, and then what you want to do is we want to have access to the Vulkan physical device And then I'm going to call this GPU. You guys can call it whatever you want. You can even just call it device, but I'm going to call it a GPU because I know it's a GPU. And I'm just going to stub up some stuff that I know I'm going to need for this device. So I'm going to do VK physical device properties. And then I'm going to do properties here. We're going to also store those properties in there. And then I'm going to do VK physical device, and the other one I believe it was features. It was features, and then I'm gonna call this features. Oops, features. And then the other one I'm gonna store is the VK physical device memory. Did I spell that right? Memory properties. So memory properties, and then I'm going to call this memory properties like so. And then the other one that I'm going to store is a boolean, and this is just going to store boolean on whether our device supports local host visible, which we will use in the future. So I'm not going to really explain this for now because we haven't really gotten to it just yet, so I'm just gonna put it in here so that I don't have to later on. Okay, so supports device local host visible. Again, because we're gonna make use of dynamic rendering, so yeah, you guys will see in the future. So let's do U32 here, and then we're gonna do graphics. What do I want to say? Graphics queue. Yeah, I want to store the index for my graphics queue. And I think I want to do for the present transfer as well. And for the present transfer and graphics, I think that's it, right? So that's graphics. And then the other one will be present. And then the other one should be transfer. Okay. Now on Mac, these indices literally can be the same, right? They can just equal one another because that's just how it is on Mac. And you'll see what I mean, okay? And then the other one I need, I think this is fine. And then all I can do, device.h, I'm noticing that it's not highlighting my U32s, so I think I might have to include my my defines.h. So yeah, we needed to do that. Okay, so back into our device.c here. What is this crying about? I know type vk instance. It's just cached, but it'll find it. So I'm gonna copy this now. Oh wait, we haven't finished this yet. So here now, we're just gonna do Vulkan physical device, and then I'm gonna do physical device, like so. And do I want this as a pointer? Yes, I do. Okay, and then the other one that I'm gonna do is select logical device like this. Okay, and then I guess that's it, right? Yeah, I guess that's it. So then the only thing I might have to change, let's see, we're creating the logical device. So when we create it, I know I'm gonna need my Vulkan physical device. So I guess I could do this. So copy this. Oh, it's actually already there. So just we're gonna pass in the physical device. And then we need to also basically pass in the VK device. I'm gonna call this logical device. I'm not too sure, but I'm gonna keep it like this for now. Okay, and then I'm just gonna copy these two functions, and in our Vulkan device.c, just paste them in there. Sweet. So the one that we're gonna start with is the physical device creation. Okay, and it might be a bit lengthy, hopefully not too lengthy. Yeah, so that's what I'm gonna do. And also, before we even do that, I believe I did not add this to our context, so let's add it there, and let's call this physical device. Now the namings here is very verbose. I don't have to say physical device. I could have just said GPU, but I'm just doing it because it's a tutorial, so I just want you guys to see and see what's actually happening, and be able to follow along pretty easily. Okay, but yeah. Okay, so now that we've added this to be part of our context, we can go back to the device .c, and then in here we can open up the select physical device function, and we're gonna basically populate. So what I'm gonna do is I'm gonna let me think. Actually, let me just consult. Kind of forgot a little bit here. Pick physical device. So we're gonna pick the physical device. So we've already have this variable. We're gonna need to get the device count. Enumerate, is the device suitable? Properties, features. Okay. And you'll notice that they're using these crazy C stuff, C++ stuff, multi-map. Yeah, it's crazy, man. But we're not going to do that. We're not going to use C. And you'll notice they're also making use of some really weird stuff, optional, which we don't have in C. So we're not going to use all these fancy C++ stuff, because I don't like them anyway. Hence why I'm not even using C++. However, they can be handy, because this definitely looks handy, but it's whatever. Okay, so, alright, got it. Now, let's do the VK device. So, let's get the device. So, we're going to need a U32 to store the device count, okay? So, let's do device. Let me just reposition my mic real quick, because I can't see my screen. So, let's do device. Count goes to 0, and then we're gonna do a VK enumerate. I think it was enumerate. It's not. What was it? VK enumerate. I'm just gonna copy this. VK enumerate physical devices. Then I'm gonna pass in the instance. We already passing in the instance through the function call. And then we're going to pass in the device count to populate. And then what we need to do is for our physical device list, we're just going to pass in 0 for now. And this is saying incompatible pointer. Oh, I just have to dereference that. And then that should be fine. Okay, then we're going to do, let's see. Okay, we're going to do an if statement. So let's do if device count is equals, well, less than equals to 0, right? So if it's less than or equals to 0, then obviously we don't have any devices that support Vulkan. So we're going to do an fatal here, and again I'm going to have to import my call logger. So let's do car / logger.h, like so. Then I'm going to do fatal, and then I'm going to type in failed to find GPUs with Vulkan support. Okay, then I'm going to return false, and that's about it. Okay, and just here at the bottom I'm just going to return true if everything is in order. And then yeah, so next what we're going to do is we're going to create an array to store the devices. Okay, because they're making use of a vector, which is something we don't have in C, so I'm just going to make use of a normal array. So we're going to have an array of physical devices. So physical device, then I'm going to call this devices, and our array is just going to hold 5 GPUs. This number, I could just say 1, because on macOS, like, we literally just have 1 GPU, right? 1 CPU, 1 GPU. It's infused within the CPU. Well, I don't know. What's the M1 chip? Is that a CPU with a GPU? Yeah, I'm not too tech savvy, but yeah, but then I do know on macOS, our physical device, we only have one, at least on the laptops, right? I don't know about the other standalone machines, the Mac Studio and stuff. So yeah, I don't know, but I know that normally it's just one. We'll literally ever have one, but I'm just gonna increase it to 5 just in case, you know. And then we're gonna do VK enumerate. We're gonna do this again, so I'm not gonna retype that. I'm just gonna repaste it in there, and then this time we pass in the devices list that we wanna basically populate with the number of devices that we have on our system. So does this, let me just do this properly. Note on macOS we only have one, as far as I know. So probably a list is useless. I don't know. That's up for y'all to decide. But again, if you want to build this engine on a different machine, then I guess you could just leave it as 5, or you can increase the number. But for me, I know this will only ever run on macOS, so I'm cool with this. Yeah. And then let's do int I goes to 0, because we are going to do I less than device.count. We are going to iterate. So let's do I plus plus like this. And in this for loop, what we want to do is we want to pick a suitable device. So we're going to iterate through the device list that just got populated by this function, and then we're going to find the device within this list that is suitable for our use cases or our needs for the engine. So what I'm going to do is I'm going to do VK. I'm going to get my properties, because you notice how they have this device suitable, and then they basically query for the properties and the features. We're going to do the same. So I might as well just copy these two functions. So I'm going to get the properties, then I'm going to get the features. So I'm going to copy that like this. And then I'm going to do, did I have memory properties? Because I want to do this right now rather than later, and no, they don't, so I'm gonna have to type that myself. So let's just do VK physical device. I think it was memory properties, and then I'm gonna do memory properties like this, and then from there we're gonna do VK get physical device memory properties like so, and then we're gonna do devices I, then we're gonna do at memory properties like so. So we're just gonna populate that, and then here should be devices I, and then add device features, fine, and then here should be devices I like so. Okay, sweet. So we now have our device properties. We also now have our device features, and we also have our device memory properties. So now we can basically, you know, check and see if the current GPU we have meets our requirements. So I'm gonna check for our base requirements first. So I'm gonna do base requirements, right? And then all I'm gonna do is I'm gonna do if device features dot sampler anisotropy. I don't know how to pronounce that. So if this is not supported, we're just gonna ldebug something here and be like GPU at index. So I'm gonna do %d does not support sampler anisotropy. Okay, and then we're gonna skip this device, so skipping. Okay, and then we're gonna do I just to populate the index of the GPU there, and then to skip, we're just gonna say continue, okay? Because now we're skipping this device, so there's no need to check for anything further because it doesn't support this. So let's look for the other device and check if that one supports it, and if that one supports it, then we can carry on defining our we can carry on checking for more support, right, that we need in the engine. So the second bit of this will be whether or not this device supports so let's just type it. So if device supports local host visible, okay, I'm gonna set this to false. And to check for this, all we need to do is we need to basically check if device supports local visible. So all I'm gonna do is I'm just gonna do a U32 I equals to 0, and then I'm gonna do I less than memory properties. Okay, and I'm gonna do memory. Is it heap count? Memory type. I think it was memory type count. And then I'm gonna do I++. And then we're gonna basically just do a pretty nice check here. And I think what I'm gonna do is I'm gonna do memory properties.memory types, and then in types, let's do property flags, and then if those property flags have vk memory dash property do they have, okay, let me just type further, property host coherent host visible, yeah, this one, host visible bit, and then we can check if that is not equals to 0, okay, and then outside here we can do another and actually let's just move this on its own line and then copy this, okay, and then just paste it down here like so. And then what we're gonna do is within the property flags, again, we're gonna check if it has instead of host, it should then be device. So from this point, so vk memory property, I'm gonna say device local bit, okay. So this is the combo that we're checking for, okay. And then if it's satisfied, right, if this if statement is satisfied, then all we want to do is we just want to populate this, okay. So we want to say supports, and then we're going to say that is true indeed, it does support. Then we're going to break out of here, okay, out of this for loop. And then once we've broken out of there, we're going to check if indeed it does support. So I'm going to copy this. So if it does support, then I'm going to do a debug message just so that I can know of that. Then I'm going to do supports host visible. Yay, you don't have to do this. I'm just doing it for debug purposes, okay? And then all we need to then do is check our GPU requirements, okay? So GPU requirements, so these were our base requirements, okay? Now we're gonna do our GPU requirements. So we can do physical device, not GPU requirements, we can say meets requirements, because if it met the base requirements, then it met everything we sort of kind of need for now. So we can proceed and basically pick this GPU to be the GPU we're going to use for our Vulkan renderer. So let's do GPU then equals to devices at the current index, okay? Simple. Then all I'm going to do is up here, notice how we queried for the properties, the device properties, features, and memory properties, but we only made use of the memory properties here. I'm gonna take all of these properties and then store them, like essentially I guess you can call it cache them or something, so that we don't have to query for them again. So I'm going to cache them, store them, or whatever you want to call it. So we're gonna do device properties equals to device properties. Okay, and then I'm gonna do the same for the features. So I'm gonna do physical device dot features equals to device features. And then I'm going to do physical device dot memory properties. Then I'm going to do memory properties. Okay, and then I think the last one is this guy, so we're going to also store that. So let's do physical device dot supports localhost visible equals to support host visible, like that. Okay, now that we have the GPU selected, we need to ensure that indeed it was selected. So let's just check for that. Ensure was indeed selected. Okay, and then all we're gonna do is if files.gpu does not exist, and then we're just gonna fatal log to the console that no physical device was selected or found. Okay, and then we're gonna return false, and then okay, yeah, I think that's fine. And then all I'm gonna do next is I'm just gonna do linfo here, just so you guys can see if this actually worked or not. So I'm gonna do selected GPU, right? Then this is gonna be a string. So I'm gonna do physical device dot I guess that is stored in physical properties. Yeah, physical device properties dot device name, like so. Okay, that should just return Apple M1 if I'm not mistaken, because I'm on an M1 machine. And then we break out of here because we've now finally selected our GPU, because we are currently still in this for loop. So because we found, we can just break out of it, right, and stop iterating through that, and then return true because we found what we were looking for. Okay, which is actually not correct. I guess we could just return true. Then here we return false if we don't find any, because it is a possibility that we don't find the GPU we're looking for. So technically, if we find it, we return true, right? Return true. If we don't meet this requirement, we skip the device. But if we don't skip it and it does support it, we go down, and then we found what we need, and then we just return that one. So then we leave and we return false. I guess, I don't know, we'll test it, right? Yeah, we'll test it. And I think that's it, really. That's all we need. So that means in the renderer, all we do now is just say if Vulkan no, don't we have this included? Nope, we don't. So let's do include Vulkan device.h. So down here just say select, wait, what was the function called? Select physical device. Let's just do this. Okay, let's do Vulkan select physical device. and then Vulkan select physical device, Vulkan select physical device, just a stylistic trace there. So here we should finally find it, and then we should pass in the instance. So how will I do that? The instance, isn't that stored in the context, and the context is global? So essentially I could just do context then instance like this, right? And then the physical device that we want, I guess that could be context, and that should just be the physical device, right? So I can do context dash physical device like this. But because we're setting it, so we need to just take in the reference to that. And I believe it also wants one here, so put that like so. And then that should be fine. Okay. So if it fails, we just return false. And I think I need to do this. Yeah. Then I'm just gonna failed to find how do you suitable? Is this how you spell suitable? Suitable Vulkan device / GPU. Yeah, I guess. I don't know. So let's rebuild this and let's run it. So let's see. Select the GPU Apple M1. So we do have our device selected now. And we still shut down successfully. Sweet. So I think I'm gonna leave it here. Okay, and then for the logical device, I think I'll make a separate video for that. Mainly because I feel like this video is a little bit long, so I don't want to bore you guys with the intricacies of this. But yeah, cheers.